Hello, I'm Adriana High, and for my mapping project, I chose to evaluate the effect of nuclear and alternative energy sources on aquatic life, specifically fish species threatened in European countries. So, my evaluations were based off data for both nuclear and alternative sources. So some of those energy sources include solar power, wind power, hydropower, nuclear, and geothermal. I'm mentioning this because it's easy to only consider nuclear as harmful to the environment, but my data does include those other less thought of sources. So I did want to mention that explicitly during the presentation. So, and progressing away from non-renewable energy sources like oil, fossil fuels, coal, there are obvious advantages to more restorable energy sources. And some of those advantages include the ability to be replenished, so the fact that they are renewable, the fact that there's little to no greenhouse and net carbon emissions. There's also economic benefits, which include the creation of jobs. With the advantages, there are certain aspects of alternative energy that could negatively impact aquatic life, mostly from nuclear or hydro power sources. So, wind, solar, and geothermal pose no significant threat to aquatic life that I could identify. So, the disadvantages include fish impingement by diverting natural surface water. The fish can be killed or injured by the turbine blades used to power hydroelectric power, electricity. The disturbance of movement and growth of fishes and other marine life. Not only that, but there are global warming emissions that are produced during the construction of hydroelectric power plants. And water flowing through dams collect nitrogen, which can damage fish and their ability to reproduce. The big controversial disadvantage comes from nuclear power plants that utilize a once-through cooling system. Its disruption of habitat includes both the intake and discharge of water. So what happens is the cooling systems are installed with filters to prevent large objects and fish from getting pulled into the cooling system, but some small aquatic life fit through and are killed during the intake process. Others become trapped in the filters. In addition, water released back into the ocean is up to 25 degrees warmer than it originally was. So the warmer water kills some fish and forces others to look for cooler waters. The warmer water also attracts non-native aquatic life that often die from cold shock when the cooling system is not in use. So this next slide, it just contains a passage from an article in which researchers conducted a study on the impact of the Forsmark nuclear plant that's in Sweden. So it was trying to see what impact it had on fish impingement. Essentially, they concluded that a lot of fish were being impinged upon, and the article offered a potential solution to the issue. So, the fishes pictured here are being impinged. It's essentially what happens when they're trapped into the cooling system. So it's obviously not a positive thing to happen. So you can compare the data for the European countries. So this is the map that I created with my data. The lighter colors indicate a lower LQ, while the darker colors signify higher. You'll notice that Iceland is amongst the highest of the LQs for the alternative nuclear energy. In fact, almost 100% of Iceland's electricity is powered through alternative energy sources. So the majority of that is through hydropower, with another sizable amount coming from geothermal power. Iceland is considered a pioneer in the use of geothermal energy. You may have also noticed that Spain was amongst the lowest LQs, so that was kind of surprising, even though in 2013, wind power accounted for over 20% of Spain's energy use. And Spain has one of the largest solar industries in the world. But looking at that more comprehensively, as we did, still shows that it's only a fraction of the energy being produced. So I was initially surprised by the data, especially after finding this map of nuclear power plants in Europe. So apparently, even though there's quite a few plants, it still doesn't account for much of the total energy consumption. It also goes back to the fact that my data included those other alternative sources that are obviously not reflected on this map here on the right. So this next map shows the fish species threatened LQs for European countries. Just to give you guys some perspective, it is estimated that there are about 30,000 or 40,000 fish species in the world. There are only about 900 found in the Mediterranean. And just for example, in Poland, there's only 8 species of fish that are threatened or endangered. So the moral of the story is that there are a lot of fish. Well, based on the maps I created, I don't necessarily see a correlation between alternative nuclear energy and fish species being threatened. However, there are a few countries that do show some consistency through each variable. So, for instance, Iceland is, like we said, amongst the higher LQs for alternative nuclear energy. It is also high in the LQ for number of fish species threatened. And then Germany is also low in both categories. Some variables that we didn't consider include the country's proximity to water, prevalence of hunting fish for food and sport fishing, and the fish's ability to quickly restore population. So obviously, had we have considered some of those things, we may have had a different sort of conclusion. But what I found was that there was no substantial correlation between the two variables that I chose. And I learned quite a bit about some individual European countries, but when it comes to alternative energy and fish species, it's not really relatable based on what I found. So the following are just the links to the data that I collected, including the articles and the numbers that I got. Okay, that's about it. Thank you for your time.